Hello everyone, this is Prashanth. Let's continue with the last lecture. In the last lecture, just we discussed about the USB sensors and embedded sensors. Along with that, just we have discussed about the various types of sensors available to develop the IoT projects. So in that USB sensor, we have different types of sensors. What are the applications? What are the advantages, features like that? We discussed in the last use case. Also, we discussed in the last class. For embedded sensors, also we have different types of embedded sensors. For that, applications, advantages, course objective, course outcomes, real-time projects also we discussed in the last class. So now we move entering into the another converter or sensors, that is analog to digital converter and digital to analog converter sensors here. Let's continue. Before entering into that, first we have to know the what is sensors. Internet of Things, these the components play a crucial role in the gathering and manipulating data from the physical world. We know here how they contribute to the principles of IoT. So here voltage sensor, the first one, voltage sensor, it can convert the voltage level into the frequency level, like that. Just we have to assume in our mind. For voltage sensor, what is the objective here? Objective and outcome: continuously monitor to health performance of devices by measuring voltage levels in critical components like batteries, power supplies, like that. Outcome, so here enables the real-time data collection for preventive maintenance, optimizing energy usage, and detecting potential malfunctions in connected devices. So this is about the objective of voltage sensor and outcomes. So next, analog to digital converter and digital to analog converter, objective and outcome, objective and outcome. ADC stands for analog to digital converter, DSC stands for digital to analog converter. So the objective of ADC is bridges the gap between the physical devices, physical and digital worlds by converting sensor data into a format and understandable by digital devices. Outcome allows integration of various sensors into the IoT ecosystem, facilitating data and analysis for better decision making. So this is the objective. This is the outcome of analog to digital converter. And digital to analog converter, objective and outcome. The objective is enables two-way communication in IoT system. It translates the digital instructions from central hub into the physical actions. That is the objective. And coming to the outcome of digital to analog converter, allows control of actuators like lights, valves or motors based on sensor data or user input. This creates a feedback loop for automation and remote control in smart homes, industries and connected environments. That is the second type, analog to digital converter and digital to analog converter. Next, DHT11 temperature and humidity sensor. Here the objective of that one is gather environmental data like temperature, humidity, crucial various in IoT application. The outcome, it provides real-time insights for applications like smart agriculture, optimizing integration, irrigation, smart buildings, controlling heating or cooling, remote patient monitoring system for ensuring the comfortable and safe environment. So these are the outcomes of DTH11 temperature and humidity sensor. These components combined with other IoT technologies enable connectivity, data acquisition. For connectivity, sensors collect data and it is converted for transmission across the network. And data acquisition, continuous monitoring provides valuable insights into device health and environmental condition. Excuse me. Automation and control, digital to analog converters translate digital instructions into actions, allowing for remote control and automated responses based on the sensor data. So these are the some specifications of that sensor. So here voltage sensors in the real time of Internet of Things, the voltage sensors are play a crucial role for monitoring and regulating the electrical system. Understanding of In the part of understanding of voltage sensor here, it is the devices that detect measure the electrical potential difference between 2 points in a circuit. The common in various types here: resistive voltage divider and transformer. Resistive voltage dividers, here these simpler circuits can use resistor to create a voltage proportional to the input voltage, suitable for lower voltage ranges. Transformer used for high voltage or AC alternating current measurements. They isolated for step up or step down. They are having two types of transformers: step up and step down. Depends on the number of windings, upper windings and lower windings, like that. These are the some facts here: resistive and transformer sensor. So next one, Hall effect sensors, auto couplers here. Hall effect sensors nothing but contactless sensors detect changes in magnetic field generated by current flow, enabling voltage measurement without physically connecting to the circuit. Just be the aim is wireless connection. And optocouplers. This isolates the sensor from high voltage circuit using light, ensuring safety and accurate measurement for AC or DC voltages. So these are the types and applications of voltage sensors in IoT: battery monitoring, solar power systems, and smart grid management. Battery monitoring: IoT device can use voltage sensors to track battery health, triggering alerts for low battery or replacement needed. Solar power system also monitoring voltage output from solar panels. It helps optimize energy production and identify potential issues. The last one, smart grid measurement. It is voltage sensors in power grids. It grids enable real-time monitoring, allowing for efficient power distribution and identifying potential problems also. These are the applications of voltage sensors used in IoT. And industrial automation also, monitoring voltage levels in machines. Process helps prevent equipment damage and ensure optimal performance. Integrating voltage sensors with microcontrollers also. So here the chosen sensor type determines the connection method. And resistive voltage divider provides an analog to voltage output readable by microcontrollers, analog to digital converter. And transformers also are a Hall effect measures the may require additional amplification or signal conditioning circuits for compatibility with microcontrollers and analog to digital converter. And optocouplers provide a digital output, simplifying integration with the microcontroller. So these are the some integrating voltage sensors with microcontroller part. Microcontroller code for voltage sensors here. Uh, the code for voltage data from the sensor, depending on the sensor type, calculations might be needed to convert the reading to the actual voltage based on voltage divider ratios or sensor applications. The voltage data can be used for various purpose. Here, the displaying voltage readings on the LCD, sending them to the cloud for remote monitoring and analysis. Triggering alarms are control actions based on the voltage thresholds. Example, notifying using the high voltage fluctuations also. Next to safety conditions to maintain the IoT projects. Working with high voltage can be dangerous. If you are not comfortable with the electrical circuits, consult a qualified electrician for projects involving the main power supply. That is the safety condition. Always follow safety precautions when working with electrical circuits, including proper insulation, avoiding overloading circuits also. Next, the last one, choosing voltage sensors with appropriate voltage ratings for your applications to ensure safe operation. Next one, these are the some learning resources. Just you can type voltage sensors with Arduino or voltage measurement for IoT projects. Just you can find the how to explain tutorial for explaining different voltage sensor types, connection methods, code examples, and project ideas, like that. So these are the some learning resources of analog to digital converter. Next to ADC and DAC. So here same actions will be taken here. For ADC converts continuous signal to discrete representation of that microcontroller can understand. Just you can, for example, this is the analog signal. Just by using sampling technique, just we can convert into the some digital signal. The digital representation of series in just 0 and 1, 1 and 0, 1 and 0, like that. 1 and 0, the number of bits determine the resolution of conversion, with more bits offering high precision of the device. So this is the analog to digital converter. Next, applications of ADC in IoT. So here we have different types of application: sensor data acquisition, environmental monitoring, and audio processing. Sensor data acquisition defines most sensors output analog signals. ADCs are essential for converting the sensor data, voltage, current levels into digital values readable by the microcontrollers. The digital data can only read by the microcontroller. The ones and zeros input. One is the high, zero for low. This data can be used for processing, control, and data acquisition. The zeros and ones. Next, environmental monitoring. The ADCs are used with temperature sensors, light sensors, or air quality sensor to convert real world environmental conditions into digital data for monitoring and analysis. So that is the second one. Audio processing. In audio applications, the ADCs convert analog audio signals from microphones into digital data for processing, storage, or transmission. So this is the applications of analog to digital converter in IoT. Next, DAC, digital to analog converter. This is the just to digital signal. It can be transformed into the whatever the input signal. This is the analog form. Application, signal control, audio signal generation, and industrial automation also. In signal control, ADCs are used to control actuators like motors, speakers, LEDs by converting digital signal into the user understanding of a microcontroller. Audio signal generator also. In audio system, ADCs are convert digital audio data into the audio signals for driving speakers or headphones. Industrial automation. It is used to control industrial process by converting digital control signals from microcontrollers into analog voltage or current output to regular valves perform. So these are the some applications of digital to analog converter: smart signal control, audio signal generation, and signal automation. Next, key consideration for uh, installing ADCs and DACs in IoT. Resolution, sampling rate, and output voltage or current range. Resolution, high resolution ADCs or DACs provide more precise conversion between the analog and digital signals. That is crucial for application demanding high fidelity, that is audio processing. Sampling rate, for ADCs, the sampling rate determines how often the analog signal is converted into digital values. A higher sampling rate is necessary for accurately capturing fast changing analog signals. Next, the voltage current range. The DACs have a specific output voltage or current range. Choose a DAC that can provide the appropriate level of your applications. These are the some key considerations for ADC and DACs. These are the learning resources. ADC with Arduino or DAC with the Raspberry Pi. You will find the tutorial explaining ADC or DAC functions, interfacing them to microcontroller code example, like that. Some project ideas also will develop. By understanding ADC or DAC, you can equip your IoT projects with the help of with the ability to interact with the analog one. The ADCs allow you to sense and collect data, analog data, while DAC is able to control actuators and generating analog signals based on the digital signal. So these are the some temperature. Next, temperature and humidity sensor DTH11. These are the two main components for sensing here. Capacitive humidity sensor and thermistor here. Capacity humidity sensor and thermistor. It measures the amount of moisture in the air by detecting changes in the capacitance, and thermistor measures the temperature by detecting changes in electrical resistance. These are the understanding of DTH11 sensor. Here, just benefits of using DTH11, low cost, easy to use, digital output, compact size. Like we have different benefits of DTH11, and connecting to DTH11 to microcontroller with the help of these pins. DTH11 typically uses 4-pin pace. Input voltage power supply 3.3 volts to 5 volts. Ground connection, data bidirectional data pin for communication and with the microcontroller, not connected. This it can just mainly full of resistor also just we use. Reading data from DTH11, just we are using some libraries like DTH library for Arduino, simplification and data encoding. Applications of DTH11 in IoT. Here, environmental monitoring, just you can record the data in the input parameter, humidity, temperature, noise pollution, like that. Smart agriculture also just we may use. Smart homes and IoT wearable devices also just we may use. Develop applications of DTH11 in IoT. These are applications and limitations. Limited measurement range. Um, Slow sampling rate, no external power supply. These are the three limitations of DTH11. Limited measurement range, not suitable for applications requiring high precision or extreme temperature humidity. So sampling rate also very slow. With no external power supply, no need to give any power supply from the source. Require a microcontroller to provide power, limiting to use in a battery powered application. That's why just we no use, no need external power supply. Alternative to DTH11 is DHT22, AM2302, and BME280. These are the three alternatives to DTH11. Learning resources, these are the just you can type DHT11 sensor with Arduino, DHT11 tutorial, just you can type. So these are the, by understanding these two, we also know huge amount of application we can develop through the sensors. So these are the hardware control part of IoT. Next, continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.